Okay, we are going to be solving exponentials with common bases. All right, so here are our steps to do that. If you just kind of look at the types of equations that we're going to have to solve, the first step is going to be to rewrite them using a common base if they don't already have one. Then we're going to use the properties of exponents to simplify, so prior knowledge. And then the new part here is our one-to-one property that says if b to the x equals b to the y, then x equals y. Okay, that should hopefully make sense. So if you look at number 1, we're not actually doing number 1, but we have 3 to the 2x minus 9 power equals 3 to the 7th. So if these two really are equal, then the two exponents have to equal each other. That's the only way you're going to get the same number out of it, right? So it's a very simple little property here. So we're going to start with number 2. And up here my exponents look like little blobs, so I have to use this so I can actually see. I've got, this is e to the 4w minus 1 equals e to the 5 minus 2w. So I already have common bases, they're e, which means the two exponents have to be the same. So 4w, bless you, minus 1 equals 5 minus 2w. So 6w has to equal 6. W equals 1. It's that simple. Okay, you're fine. Okay. Any questions about number 2? So if they're already equivalent bases, then you're good. So let's look at if we don't have a common base. We're going to start with number 4. All right, so on number 4, I have a few options as to what I can do for my common base. I don't have a common base, so I can't say, like, this is to the first power. I can't say 1 equals a squared minus 4, because that's not a true statement. So could I use 4 as my common base? Yeah, because 4 times 4 is 16 times 4 is 64, so I'm good. So I could use 4. I could use 2. I could use 1/2. Like, I got a lot of options here, but might as well just use 4. So if I use 4, then over here, 4 to what power gives me the 1 over 64? Negative 3, good. So 4 to the negative third equals 4 to the a squared minus 4. Once you have rewritten them with common bases, like I have now you can use the one-to-one property. You can't skip that step. And we can say that negative 3 equals a squared minus 4. Then we just solve it. It's a quadratic, so the first thing you want to do with quadratics is to set them equal to 0 and see if that can help you. So 0 equals a squared minus 1. So what do I have there? Difference of squares. So 0 equals a plus 1 times a minus 1. So a equals negative 1 and 1. And if you wanted to do plus or minus, that's fine. But I have a set of numbers, so I put them in the little brackets, since I didn't just have one number. Okay? Everybody good so far? All right, good deal. All right, so now let's look at number 5. So for number 5, I have 2 to the m minus 9, and 30 equals 32 to the m plus 3. So what's our common base going to be? 2. All right, so I'm going to have 2 to the m minus 9, so that stays the same. 2 to what power gives me 32? 5. So I'm going to have 2 to the 5 times m plus 3 power. So I have a common base. Now I can just set the exponents equal to each other. So m minus 9 equals, and then I can go ahead and distribute and get 5m plus 15. That means that'll give me 4m equals negative 24. M equals negative 6. Oh. Now my pen doesn't want to work right. All right. Any questions at all? We're good? All right. Let's go ahead and do number 6. All right, so on number 6, what do you think we could try as our base? 7. Like if we really think this is going to work, I mean, this kind of narrows down my choices right here, even if you're not sure what to do with that. So 7 and 7 is all I got here. So 7 to what power would give me 343? Seven to what power gives me 343? Third. Okay. I'm sorry. I don't know what we're saying there. So I'm going to have 7 to the 3 times 2n minus 4 power equals 7 to the negative 2. Right? Is that n plus 4? I can't. Okay, thanks. It's just like a blob up here. N plus 4. Okay. Then y'all go ahead and finish that one up. Any questions at all? Did we get 1/2? Yes. Okie dokie. Let's look at number 7. So, number 7, I thought I caught all these and I still missed one. I lost a fraction bar, so put that one back in. All right, so here I've got 1/4 and 1/64. So I've got some options as to what I can use for my base. I can use 1/4, I could use 1/2, I could use 2, or I could use 4. So it doesn't really matter, but you might as well, if you can use 4, because 4 times 4 is 16, times 4 is 64. If I can use that 1/4, might as well just leave it like it is and not have to do anything on the left-hand side. So I can leave this as 1/4 to the 2x squared minus 6 power equals, and then 1/4, if I take that to the third power, I get 1/64, so this is 3 times 2, is that a k and not an x? It's an x, okay, I knew there was a k somewhere, these are just weird. 2x squared minus 5. Okay. So now I have common bases, take them down, and I get 2x squared minus 6 equals 6x squared minus 15. Quadratic, so I'm going to set it equal to 0. So 0 equals 4x squared minus 9. Can I factor that? Yes, because that's a what? Difference of squares. 0 equals 2x plus 3, 2x minus 3. So x equals negative 3/2 and 3/2. Any questions? Okay, if you don't have any questions, then I want you to do number 9. And as I start working it, I don't want you to just copy mine down. You finish up and then we'll check ourselves. All right, are there any questions at all? Did I give you enough time? All right, so then I want you to, once you've got that one figured out and make sure we agree, ask me any questions you have. And then I want you to also do number 10. And as I start working it up there, no, I'm going to give you some time before I start. But when I start, there's different options for the base. So if I use something different than you did, that doesn't mean you're wrong necessarily. So don't erase and just copy mine down. You finish yours, then we'll see if we agree in the end. So move on to number 10 once you've agreed or gotten your questions answered on number 9. Any questions at all? Anything we're stuck on? Anything? Yeah, we'll get there in just a second. Let's finish number 10. All right, so on this one thing I want to make sure that you understand is that from here to here, using the one-to-one property, that is the only new part. So if you struggled with this at all, and it wasn't from here to here, then it's not pre-cal that you're struggling with. If you struggled getting from here to here, that's just number sense. That's pre-algebra stuff. That's just knowing how to multiply in your multiples of numbers and whatnot. From here to the actual answer, that's just basic algebra. That's not pre-cal either. So if those are the things that you're struggling with, then you're struggling with prior knowledge. You're not struggling with the pre-cal, which is this right here. These are the skills that you needed to come being rock stars at already. All right. Okay, so let's look at number 11. Are there any questions on 10? And you could have used 2 as the base as well. And if you use 2 as the base, that's totally fine. Your numbers here, here, and here, or even here will look different. But in the end, if you did it correctly, you should get the same answers. It's fine. You just factor out a different number here. Okay. All right, so let's look at 11. So we sort of have common bases, but not really, because I don't have one exponent. I don't have one base on each side, but these are the same. So if we multiply 2 things that have the same base, what do we do with the exponents? We add them, okay? Just like if you have x squared times x cubed, that's x to the 5th. So it's the exact same rule right here. So we're going to have 5 to the c minus 1, these look like blobs, plus 3c plus 2 equals 5 to the 7c plus 16. So now that I have the common bases there, now I can use the one-to-one property. This gives me 4c plus 1 equals 7c plus 16. Get 3c equals negative 15. C equals negative 5. Okay. So you have to be able to recognize your exponent rules in times that don't necessarily look like what you're used to seeing. So I'm going to show you one example of how you would use this stuff in calculus, kind of going the other way. Here we're combining them, but I would also need to be able to split them apart. So you might get something that looks like this, e to the 3x plus c power. So in calculus, you're going to have a lot of stuff that has a plus c on it. Once you start taking derivatives and integrals and whatnot, and c is just a constant, it's just a number. So that means this could be 3x plus 5, could be 3x plus 20, could be 3x minus 17, who knows. But if I have this, and I've added these, and I know how this works here, then this is the same thing as e to the 3x times e to the c, if I split it apart, right? Because then when I multiply those 2 bases, I just add them back together. Well, this is a variable, so this value can vary. This is a constant. This e is a number to some number power. So that's like saying 4 to the 8th power. Like, that's just a number. So instead of leaving it with exponents here, I can rewrite this as a, some number, times e to the 3x power. And when you do things like this, you're actually going to skip this step. But when you do go from here to here, that can't blow your mind. It's because you're using your exponent properties, okay? That's why it's important to understand them, not just because we're doing x squared plus, or x squared times x cubed or something like that, okay? Are we good? All right, y'all do number 12. let me know if you have any questions. And once you add these and you get to this, hopefully you can factor that pretty easily and get this answer. Are we good? Awesome.